Okay, welcome everybody. Thank you for joining. So I'm just going to be presenting on web application security. So hacking web applications. So I'm going to be talking about SQL injections and cross-site scripting and also CSRF. So there's like a lot more in web application security, but since our time constraints, so we're just going to cover a few of the topics, which is like SQL injections and XSS. And we're also going to touch a bit upon CSRF and also mobile hacking. So for mobile hacking, I'll actually go through an article that I had written on how we can create malwares uh, in mobile applications. So we'll be going through that. So let's go ahead. So exactly what I said, what will be covered. So first I'm going to show you an introduction to hacking, and then SQL injection, and then XSS, CSR, and mobile hacking. So the worst feeling that you could ever get after creating your application or building your application is when your data has been hacked. So this is just like a message which was kind of like a funny thing to put out, but yeah, congratulations, your customer data has been hacked. So it's usually in real life, it's not a funny thing or a humorous thing. It's very like it's very dangerous, and it also costs a lot because a lot of loss. Several companies have been hacked over the years. If you would have watched the news, there have been a lot of news about companies being hacked, companies being breached, and all of that is because the security knowledge or the security awareness has been pretty low. So it I'm really thankful that this opportunity has been given to like kind of provide the security awareness. And so, talking about web app security or hacking in general, I just wanted to show you this house. So let's just think of our web application or any asset that we have as this house. So if you look at from attacker's perspective, an attacker is always going to find out how to get into the house or the web application, right? So how to get into it is always going to be the first question an attacker is going to have. And if we are going to look at this house like a web application, then we have to first find out, we have to think from an attacker's perspective, and we have to first find out how an attacker can enter our house. So this is essentially just like when a robber goes to rob a house and he's going to case the joint. Like that's a term. So essentially, if you look at this house, what would you say are like the entry points? How could they enter in, right? How could somebody enter into this house? So if we see, they could enter in through these different places. I've just shown a few. There may be different abilities or different gateways that they could enter through. But just looking at this in the front, I've said that they could maybe enter through the sliding door, or they could enter through the door itself. They could enter through this window over here, or maybe if they had a ladder, they could climb up and enter through this window on the top, or they could even enter through this hidden window. So an attacker usually analyzes every single part of what they need to overcome in order to get into their target. So similarly, when it comes to web applications, there are also these components which can also be taken as the attack surfaces. Like for example, if you saw in the case of the house, the attack surface was like the door or like the window, or it was also the sliding door, right? So similarly, even web applications have their components which are attack surfaces. So for example, in web applications, we have the server. So the server could be running on the server's end, which will be like an Apache server or an Nginx server, or it could be even nowadays we even have cloud virtual servers. So it could be any type of server that's running on the server's end. And if that server has any vulnerability, the attacker would be able to exploit that vulnerability and gain advantage over it. Similarly, front end. So front end is essentially just our web page, right? What the user sees. So when we're building a web page, we're going to have a server, we're going to have a front end, we're going to have the client. So the client is essentially in the user's end. They may be using Chrome browser or Internet Explorer or Firefox or Brave browser or whatever browser that's out these days. And the other component also includes the backend or the database. So there are different databases like relational, non-relational. So there's like relational, an example is MySQL, and non-relational, you have MongoDB. So MongoDB does not have tables, or it does not have columns, or um, it's not your relational database in that sense. Where if you have experience with MySQL, MongoDB is totally different from MySQL. So it just has collections, they call it in MongoDB. And also third-party integration. So third-party integrations is something which people leave out, but it is really essential when you're using a web application, because sometimes when you're building a web application, you might need help from a third-party application, maybe to get some data in, or maybe to perform some processes. For example, maybe if you have like a 3D generation website, you might be using some other 3D model from another website, or maybe a 3D algorithm from another website, right? So that's usual. People use it a lot. So even those integration and plugins are attack surfaces, and they're like very big attack surfaces, which we need to keep an eye on, and we need to be ready so that we can overcome these, right? And anytime through the presentation, if anyone has a question, you can just feel free to ask, and I'll try to explain as much as I can. So now, what are the most common web application vulnerabilities, right? When it comes to web application vulnerabilities, there are like so many that we cannot contain it within like just a few pages or like even a book. There's like so many vulnerabilities, but OWASP has like come up with like the top 10 vulnerabilities. So OWASP is like one of the security researching groups who every once in every 4 or 5 years, they let out like the top 10 list of the top 10 vulnerabilities. They have lists for web applications, and they have lists for mobile applications, and they have lists for even networked vulnerabilities. So from their list, I've just taken a few out. So a SQL injection is essentially just structured query language injection, and it's always been on the top. So for almost like nearly 10-11 years, it's always been on the top 10 list. And then there's cross-site scripting and CSRF, SSRF, and IDOR, broken access control. So IDOR, broken access control, and SQL injection have been like from the beginning, since MySQL, or even structured query language, any SQL, like there are different types of SQL languages, SQL databases. So since any of those servers began, there's always been SQL injection. Like it would be surprising that how even after these many years, SQL injection is still a big problem, but it actually is. Because essentially, if you see in hospitals and other government agencies, they still use the old systems. They even use like Windows 98 systems, Windows 98 servers, and they also have like the old MySQL databases or MS SQL databases. So that so the web vulnerabilities have been really huge even up to now. And the next is we're going to talk about SQL injection. So I just put a small thing here. I own your DB now. I own your database now. So SQL injection has a very huge attack surface. Essentially, if you do not sanitize your inputs, or if you don't escape your inputs properly, it's a real big problem, and it has been a problem for very long. So first, to understand SQL injection, we need to understand what is SQL, or structured query language, right? So we have to start from the base up. So SQL, or structured query language, is just human readable language that we use to talk with databases. It's just a simple query kind of language. We just type in queries, and we get, it's kind of like a communication between us and the database, right? And so there are like different types of servers that have different implementations of SQL. So there's like SQLite or SQLite, or there's PostgreSQL, and there's also MS SQL. But the most common type of SQL is MySQL. And there's also Oracle, which is another type. Oracle has almost similar structure in the queries, but it's a little bit different. So nowadays, like I said, there are also like NoSQL types of databases, such as MongoDB and Google's Fire also. So there are like so many more databases like that. And SQL works on three basic structures: database, tables, and columns. So that's a hierarchy. So the database is the topmost. Database consists of several tables, and the tables consist of several columns, with the columns have values within them. So here is an example SQL query. So we're going to talk about just a basic SQL query. So if you can see here, select ID, name, SSN, comments from records where name like Jack. So this is essentially a basic SQL query. So I'll just explain what this SQL query means. Okay, so firstly, before that, I should say that SQL is case insensitive. So you don't need to capitalize these select and from and where or anything. I just capitalize them here so that it looks it looks a more neater or easy to understand, so that we can differentiate the query part from the tables and the database and stuff. So if we see here, ID, name, SSN, and comments, 4 of these are columns, and records is the table. So the structure is essentially select the columns from the table where the column name like Jack. So we're just saying that if there is a column name, and within that column, if there is any row which has Jack in it, then we'll display that. So that's all it means. It's pretty simple. And within SQL, you can also do one more cool thing called subquery. So subquery is a very important topic when it comes to SQL injections, second order SQL injections. Like second order SQL injections are essentially like higher or advanced versions of basic SQL injections. So subqueries are really helpful there. So subquery is essentially just adding another SQL query within an SQL query. So if you see here, there is select, and we have these columns from bio, which is the table, where ID in, and then we have another query over here. So this in itself, select ID from secrets, that in itself is a separate query, but we are also giving it within this entire big query over here. So that's how subqueries work. And if you want to know more about SQL, you can head over to like Wikipedia or like the W3 Schools link, and they have some vast amount of resources for structured query language. So, and also one more thing I wanted to say is when we have a web page or a web app, usually what we do is users cannot see the SQL query. We write the SQL query on our end, and it is executed on the server end. So on the client end or the user's end, they're not able to view the SQL query. So they only have like forms, like for example, they might have a login form, right? Or they might have like an update form, or they might have a form where they have to register, or they might have a form where they have to enter their name and their email address, right? So when they enter those details, how are we getting it from the application or the front end? How are we getting it to our database? So we do that using something called parameters, right? So for example, this $first_name is a parameter. So every data that is there that the user inputs is stored in a variable on the web application, and it's carried over from there over here to our database. And this first name is that such type of variable. So $first name that I've given here is like from PHP. The structure is based on PHP. So in PHP we use dollar and the name for the variable. So I've given $first name over here. So can you like spot any potential error over here, something that could go wrong, right? So what could go wrong is if the first name parameter that we've given here is directly provided by a client. So suppose a user who's using our website, who's able to enter the details, if they are directly giving it into our website without us doing any kind of checking or sanitizing or looking at their input, if we just take it directly without any security precautions, then it's going to cause problems. And let's see what type of problems it's going to cause. So first, what is SQL injection? So SQL injection is essentially just a basic kind of vulnerable web vulnerability where we take SQL queries and we manipulate it according to our own wish so that we can get privileges or we can access some data that we are not supposed to access, right? So we saw from the previous page that select star from bio where f name is equal to first name. So this dollar first name is in direct control of our client, right? Whoever is our client, it can be somebody from India, or it can be somebody from China, it could be somebody from the US, it could be anybody anywhere. So that person essentially has full control over this element over here. That is the first name. So what if the user set the value of the parameter first name equal to hack you? So not just hack you, but in between the hack and you, the user sets a single quote over there. So what if the user does that, right? So then when this first name's value, that is hacked single quote u, is passed into the database, then it gets passed like this. So it goes from select star from bio where f name is equal to first name. From there it goes to hack and then u. So essentially this code that we gave over here closes this entire thing, and the u is an extra one that goes out. So u gets out of the string. It gets totally out of this entire statement, which further causes a syntax error. So this is essentially how SQL injection takes place. So the SQL syntax is just like this, but since we are giving some kind of special character, maybe the special character could be like a single quote. So what happens is this single quote essentially closes the previous statement, and there is some extra text over here. So that extra text is the reason that we have a syntax error, and that causes SQL injection. But this is like a simple case. We're not doing anything like that's so big or that's so dangerous. We are just adding like a single quote over here, and we're giving you. So that doesn't cause a lot of impact, right? So how could we manipulate this to perform something much bigger on a more higher scale or a more higher level? How could we get more deeper? How could we like manipulate it so that we can log in without having the password? How can we manipulate it so that we can get user data or user details without having the password? Or how can we get user passwords, right? So that's what we're going to see how to do. So let us take the following SQL query. So this query is essentially a query that we'll use on the backend to authorize a login page. So only if this query returns true, only then will the user be allowed to log in to the application. If this returns false, then the user will not be allowed to log into the application. So let's assume that users over here, this user table is a table which has 3 columns, right? So it'll have the column ID, username, and password. So it has 3 columns, and the name of the table is users. So let us assume that there is stored in the table a user by the username admin. So let's just say that there is a username called admin. So that is the admin user, and the admin user data is also stored in the same table. Okay, and obviously we don't know the password, right? So we don't know the password for the admin's login information. So how are we going to log in? So there are essentially like so many ways to do this. There are like I guess there would be like maybe even more than 20 or 30 ways to do this, but I've just taken like the 2 basic ways, the 2 most basic ways that we can do this. So essentially the first way is in the username field we could give admin, because we already know that there's an admin username, so we're just going to give it as admin. And in the password field we're going to give single quote or 1 is equal to 1. So essentially, I'll explain what this does over here. So this is just a basic Boolean functionality that's going on over here, right? So before this, if you see, both of these parameters will pass in like this in the backend. So if you see, it goes select star from users where username is equal to admin. So admin is taken in completely, and password equal to. So there is already an opening single quote there, but we gave another single quote here. So what it does is it closes this. So this is empty. So when this is empty, the password for admin is not going to be empty. It's going to be some password. So this will actually return false. But what happens now? We are adding another OR. So since we have this OR here, OR functions, as you know, it's a Boolean function. This should be true or this should be true. So if either of these statements are true, then the password will be true. So when we're giving OR over here, this is not true. So it will go to this. Once this is not true, once this comes out to false, it will go to the next one. So now when we see over here, we gave a single quote 1 single quote equal to single quote 1. And then there's already another closing single quote over here. So this one is obviously equal to this one. So this statement comes out to be true. So now what happens is, since though this is false, though this is empty, though it is false, because we have an OR statement here, an OR operation over here, a Boolean operation, since we have that, so here 1 is equal to 1 is always going to be true. So because of that, this password returns as true. And we know that there is a user name whose name is admin. So this also returns as true. So since this returns as true and password returns as true, so since there is an AND over here, true and true gives true. So the entire SQL query will return as true, and we'll be able to log in as the admin user. It's pretty simple. So it's just, so again, I'll just go through what we're doing. Username, we're going to give admin. We're doing this because we already know that there's a user by the username admin. And password, we don't know the password of the admin user. So what we're going to do is we're going to give single quote space or space single quote 1, close the single quote, equal to, open another single quote and give another one. So now what happens over here? The admin that we passed is taken in properly. It returns true. And then we have an AND over here. So we should also look at the password. So when we look at the password over here, there was already an opening single quote, but we give another single quote. So when there's another single quote, it acts as a closing single quote. So this part over here is empty. So this empty part is going to return false. But we have an OR over here. So we go to the next part. So that part is 1 is equal to 1. And 1 is equal to 1 is returning true. Thus, this will turn true. So this entire password will turn true. Username is already true. So username and password is going to be true. So the entire statement will be true. And we'll be able to log in as the admin user. And then a second way. So the first way was pretty, it's easy, but it's also like you have to remember or equal to, and sometimes if we mess it up, it might go. But second way is more easier. It's like the easiest way there is. So here what we're going to do is we are only going to provide a value in the username field. We're not going to worry about the password field. Password field, we're just going to leave it empty, or we can give any random value. There is no use whatever we give in the password field. So what we're going to do in the username field is we're going to give admin the username that we know is there, and then a single quote, and then double dash. So this is one dash and then another dash, and then a space, and then some random characters. You can give any random characters. I just give ASDF. You could give any random character, or you could even leave empty. But the main important part is after the double dash, there should be a space. Always after the double dash, there should be a space. And I'll explain why it should be there. So if you look at the SQL query over here, it will become select star from users where username is equal to, there is already going to be an opening single quote there, then admin closing single quote. So admin will be taken as a username, which will return true. And then we have these double dash space ASDF. So the good thing about SQL queries are that in SQL, double dash space means everything after this is going to be comment. So everything after this double dash space will not be included in the SQL query. So the SQL query will essentially stop at select star from users where username is equal to admin. That's all. It's going to stop there. It's not going to be worried about the password part at all. So since this admin is going to return true anyway, because we know there's an admin user, it's just going to directly log in without worrying about us passing any password in. So it's, yeah, it is pretty scary. If anybody is able to log into our account, if this is fine if it's like a normal application. Imagine if it's like a important application where you have your bank details, or if you have your SSN, or if you have your Aadhaar information, it's going to be pretty devastating then. So how do we fix this? So we saw how to manipulate it, right? How to manipulate the SQL query so that we can get in. But then how do we fix it? Because fixing is the most important part. If we know that some kind of vulnerability exists, and if we find it, it's good. It's a good thing that we found it out. But what are we going to do about it? That is the most important part. Because if we just see something that's wrong, and if we don't fix it, then there's no use of us saying that it's wrong, right? So the first most obvious solution, if you would have gone through, you would understand that we have to escape the single quotes, right? That's pretty easy to understand. So we could replace the single quote character with a backslash in a single quote. Or if they are gonna use a double quote character, we could replace that with a backslash double quote character. When if we are using PHP as our programming language for a web application, then we can just use this MySQL escape string function. So this MySQL escape string function is a very handy function. It does all of this escaping, the single quote to backslash single quote, double quotes to backslash double quotes, and many more other common payload characters will be escaped by this functionality itself. So you don't need to go and manually do it, because like if there are just one or two payloads, just one or two characters like single quote, double quote, we can go we can go and like we can escape them. But what if like there are so many, like for example the comment characters I said, double dash and then a space. So like that there are so many more special characters that an attacker could include. So for that we can't just go and add each and every one. We can't go and escape each and every single character on our own. That will be tedious. It's a waste of time as well and a waste of resource. So for that we can use this MySQL escape string function. So it automatically escapes the most common payload characters. But what if, because you know in web applications there is this concept of encoding, right? Each web page can have a different kind of encoding. Like one may have a UTF-8 encoding, one may have an encoding from Microsoft, one may have some other encoding, right? So we have to take that into account as well, because sometimes we may just say that a single quote is there and we're going to check for a single quote and we'll escape it with a backslash single quote. But what if the attacker encodes the single quote in some other encoding format, right? What if the attacker is not using the same encoding format that we are using, and he encodes in some other encoding format? What then? So this problem arises because the browser or the web page, it can understand any type of encoding, right? We'll set our website or web server to only one encoding, but the browser can understand any type of encoding. So it will be able to take the user's data and it will be able to de-encode it to that single quote. So when it goes to a database, it will easily de-encode it and it will get it. So even that kind of encoding, character encoding, we need to take into account. So for that, we can use the MySQL real escape string function. So again, this is when you're using the PHP programming language. So for each languages, they have like different functions, but the functions sound similar. So in PHP, it's called MySQL real escape string. So this can be used to not only protect against character encoding, but also escaping the malicious characters, the payload characters, it can be used. So you don't need to use the MySQL escape string. You can just use the MySQL real escape string function. So that's how we essentially fix this. This is like a very basic level of fixing. because there is more kind of advanced SQL payloads, and there is more advanced SQL injection that we'll take a look at briefly. But yeah, this is like a basic way you can kind of prevent any user from attacking your parameters essentially. So more SQLi, more SQL injection. So it is fun when you're trying to log in as admin, right? It was pretty easy also. But what if we wanted to access and retrieve some important information, right? What if we wanted to get into the database, and if we wanted to get into some of the table, or if we wanted to get their company data, right? How do we do that using SQL injection? So here is where in SQL injection, there's an operation called union, which comes into play, right? So union is essentially what the name says. It just allows us to union or combine two separate SQL queries. So one SQL query, you can union it with another SQL query. So the problem with union is that when you have one SQL query and another table, right? Both the tables and both sides should have the same number of columns. So only if both the number of columns of both the tables on both sides of the union query is same, only then we'll be able to use this union query. Otherwise, it will be of no use. So as a user, let's say we are a user, we have no access to the source code of the website. How do we find out the number of columns of the table, right? So only if we know the number of columns of the table, we'll know how to manipulate it, right? So that if we know the number of columns of the table in the user data in the user table, only then we'll be able to identify how many columns we can give here. So if in the user side it has 3, then we can give 3 here. If it has 4, we can give 4 here. But how do you find that out, right? So the most simple basic solution, we need to brute force the number, right? So how do we brute force that? We're going to use response codes. So each website, as we send a request to the website, as the server sends back the website, it sends it back with a response code. The response code is always there. So for example, there are so many response code like 200. 200 is the response code for OK. The 200 just says that the request was sent and the response has come back correctly. So there's no problem, right? That's 200. And then sometimes there's 404. So I think 404 is one of the most common error response code where the web page is not present at the server itself. The server itself does not have the web page. And then we have 500, which is like a server error. And then we have 300, which is like authorization errors, right? So we have so many different response codes. So if your application is supposed to act correctly, it should provide the 200 response code. So if there's a 200 response code, we know that the application is working properly. If there is some other response code to the parameters that we've entered, that means that something is going on in the backend. And that's why it's giving us an error or a different response code. So let's go ahead. Okay, so I'll show you how we can use the union query or the union operation essentially. So the syntax is very simple again. Select star from users. So star, I don't think I explained much about that, but star just means all. It's a wildcard character, which means all. So we're going to select all the columns. And again, we are doing this. We'll be passing this thing as a parameter or as a field, as an entry to some field, for example, a username field or something. We'll be passing this part. So this entire select star from users, we'll not know what it is because it will be on the server end, right? So we'll not know what this is, but we'll be passing this part. So for example, let's say that select star from users, union, select 1, 2, 3. We are selecting 1, 2, 3 over here because for now, essentially, I'm saying that the users table has 3 columns. So I'm saying 1, 2, 3, right? So what if we don't know, right? That's when the problem arises. So let's take an example. Let's say select star from users where ID is equal to $ID. So this is our, let's say there's a web page, and in the web page, they're asking us our ID, and this is the backend code for it or the backend query for it, right? And let's assume that the table user table has 3 columns: ID, name, and password, and that the name is returned on the web page. So when we give an ID, let's say we give an ID 1. When we give ID and we hit enter, then the name of the user who has that ID 1 is returned on the web page. If we enter ID 2, then the name of the user who has a web page, who has that ID 2 is returned on the web page. So now we're going to see how do we leak the MySQL server's version number, right? So what should we set the ID value to be then? It's very simple. So the ID parameter, we're just going to give 0, right? We were going to give 0 because that will be an ID. Or you could, if you know that there is an ID that works, right? We can give 1 or 2 or 3 or whichever ID works. I've just given 0 over here as a baseline. And then we're going to union, select, and we know that there are 3 columns. So we need to provide 3 columns this side as well. So we're giving 1, comma, version, comma 3. So version is a function using which we can get the MySQL server version. So we're giving version over here, and we know that the name gets printed on the website. And that's why we're giving it in the second column. We're not giving it over here because 1 is the ID. 1 is ID. It does not get printed on the website or the web page. 3 is the password that also does not get printed on the web page. Only the name is returned on the web page. Thus, we give it in the second. We give it in the second position version. So now what happens is when this is run, the area where the name was displayed on the web page, that will be having the MySQL version. So instead of name, we'll get the MySQL version. So that's how union works. For union, you need to have the same number of columns. So to find this number of columns, what we do is we just use union select 1, or we can test it. So we can keep testing from 1, 2, 3, 4, 5, 6, 7. So we'll give 1. And if it throws an error, we say that, okay, there is maybe more. So then give 1 and 2. Then we'll test that. And if it throws an error, again, we'll say there is more. So essentially, I'll be taking you through a practical on how to do that. So it'll be coming in a while. If you don't understand it exactly now, it's fine, because we're just going through the basics now. And when I show you the practicals, you'll be able to understand it more. Next, so just like union, we have another query or another operation that we could leverage. And insert is like a very powerful operation. Because insert is the operation through which we are inserting stuff into the database. We're inserting some amount of information into the database. So here we are actually stepping into the zone of second order SQL injection. So second order SQL injection is essentially just stored SQL injection, like we are entering it and we're storing it and we're getting the reflection of that. Because if you had seen the SQL injections before this, it was more of we're just typing in the username, or we're just typing in something and it gets reflected over there, but none of our data is being stored on the server end or on the database. But when it comes to insert query, all of the data is going to be stored on the user's end, on the database. So the insert query, and there's another query that works in a similar way, which is the update query. So insert and update queries essentially are kind of second order SQL injection worthy, because the data that is being sent, that we are manipulating, is going to be stored on the server end. So it could cause havoc, or it could wreak havoc for like a long time. However long your data stored on this database server, it's going to be an issue for them, right? So let's just say that we have a registration page, okay, and we have a username field which is vulnerable to SQL injection. Let's say that the password field and the full name field, we have like done our SQL query escaping and stuff like that, but the username field, somehow we forgot it. We thought we made it immune, but it's left vulnerable, right? It happens, like when developers are under pressure and they don't have time, they sometimes just rush through it and they just leave out some stuff. It happens in real life too. So this is the syntax for an insert query. Insert into users, the table users, and then we're going to give the column names, username, full name, password, and then the values for those column names. So make note that the order in which we give the column name is the same order in which we need to give the value specific to that column name. So for example, username, then we have to give $username over here. We can't give $pass over here and expect that to be stored in password. That's not how it's going to happen. It's if you're giving something in a sequential order over here, that's the same sequence you need to follow and the values as well. So in this query, we're just saying insert into users the username, full name, password. Similarly, the values, we are passing the variables $username, $full name, and $password from the front end, right? We're taking it from the users and passing it here. So here we could make use of subqueries. So do you remember the subqueries that we talked about before that I told that could be really useful later on? So that's what's happening here. Here we could make use of subqueries inside the insert query as follows when we provide the value of username, right? So let's say that the username value we're providing some underscore user, closing it, and then comma select version. So this version, as I already said before, we know that it's going to provide the MySQL server version, right? And then comma password. So essentially how it is going to come here into this SQL statement is over here below. Insert into users, username, full name, password, values, some user. So this some user over here goes here, and then there's a single quote. So that single quote essentially closes this because there was already an opening. If you see here, there's already an opening quote, right? So that closes it, and then we give comma. We've given this comma over here, and then the second element to this value. So second element is supposed to be full name, right? But the second element over here is select version. And then the third element we've given is password. We just give the password as password. And then we're giving again the double dash space. So what happens after the double dash space, everything over here is not taken in. So the $full name, $pass is not taken in. Only this part, username, full name, password. So some user, select version, and password is taken. So now what happens is in the database, this some user is put in as the username. The version, MySQL version, is put in as the full name, and the password is put in as just password, just PASSWRD. So this seems very simple, right? We're just putting the select version over there. It's not very damaging or pretty big. But what if the user wanted to maybe send some kind of malicious code into that, right? What then? What if the user wanted to put a backdoor in? What then, right? It's all possible. It can be done. It's just complex, but it's still possible. It takes a lot of time, a lot of understanding of the structure and syntax of SQL queries, but it is possible. So that is very important. Insert is also a very important query where we need to take a lot of precautions to escape or sanitize the input that is being sent in directly from the users. And so, okay, so now we're going to talk about the first practical. So all the practicals that I'm going to show you is from Portswigger's Web Security Academy. So it's actually free for everyone to sign up in Portswigger. And I'll just share my wider screen so we'll be able to see. So Portswigger's Web Security Academy is essentially by Portswigger, and they have like a lot of labs. So if you see here, they have something called Academy, which anybody can log in, and you can just sign up for it. So you just need to create an account on Portswigger's website, and you'll get access to it all. So Portswigger is essentially just a security company, and they also create tools, security tools. For example, one is Burpsuit that you can see over here. This is an example tool that they create that helps with web security, vulnerability scanning, and finding out more information about the vulnerabilities. So essentially what we're going to do now is we're just going to go and take a look at a few of the labs. And one of the labs that I wanted to get is this one. So essentially I'm just going to show you a basic login, how to bypass a login. So we already talked about the login over here. We would have talked about it before. How they log in. So if you saw over here, we talked about how the two methods of logging in, the two ways. So I'm just going to show the second way over here. It's going to be pretty easy. So I'll just show that over here. So anybody can access this. So if you want to, you can even follow along with me if that's possible. I can even wait if you want to go ahead to the website, Web Security Academy. If you want to go ahead to the website, and if you want to follow along, you're welcome to do so. So I'm just gonna show like a basic thing. So once the lab opens up, I'm gonna go ahead to my account. I can even provide the link in the chat if it's required. I'll probably do that. So first practical. So I'm just adding this link in the chat. So anyone who wants to follow along can just follow along. But also you'd have to create an account first. So make sure you do that. And so once I get over here, so it's always better to read the lab description. So it says that the lab contains a SQL injection vulnerability, and to solve the lab, perform a SQL injection attack that logs into the application as the administrator user. So here they have essentially given us the username, but we don't have the password. It's exactly what we talked about before. We have the username, but we don't have the password. So how are we going to do that? We're going to use um, a pretty simple way two that I showed before over here. We're just going to do this, and we'll be able to log in. So I can show over here. I'm just going to type in administrator. So we know that, and then a single quote dash dash space, and you can type in anything you want. I'm just going to type in that. And password, you can leave it empty, or you can maybe just type in whatever you want. I'm just typing in a random password, nothing special. So now if I click login, it's going to log in. That's it. I'm logged in as the administrator. And I can even update my email account if I want. That was pretty simple. Again, I'm going to show it's pretty simple. It's very easy. It's just all we're doing is we're typing in the username that we already know, that is administrator. And then we're giving the single quote. So this single quote, what it does, it closes the single quote that was opened in the backend query, right? So it closes that. And then we're giving dash, another dash, and then space. So this dash dash space tells the MySQL database to consider everything after this as comment. So this password, everything will be a comment. So you can just leave it with dash dash space, or you can add some kind of random data if you want. I just left it with dash dash space, and it asked me to fill in a password from the front end. So I'm just going to fill in some random password and hit login, and I'm going to log in. That's it. I've logged in now. It's as simple as that. Very simple. So that was our first practical. And the second practical is going to be another one. It's going to be SQL injection, but we're going to use the union query this time. So I'm going to put this into the chat as well if anybody wants to follow along. And now we're going to head to this. So SQL injection union attack, determining the number of columns returned by the query. So what we're going to do here is we're going to find out the number of columns that is being returned. So we're going to use the union. As I said before, that we have to use union. So for union, the only thing that was really important was we had to have the same number of columns on both sides of the union query. So that is the one constraint that we have to follow. So for that, this lab is essentially just determining how we can brute force and identify how many number of columns are there on in the users table, right? So as it says here, to solve the lab, determine the number of columns returned by the query by performing an SQL injection union attack that returns an additional row containing null values. So I'm gonna hit access the lab. And it's loading. So before that, like we spoke over here. That's essentially what I'm going to do. Nothing big. So if you see over here, we have a page where it says we like to shop, and then we have a page where we can view details about the specific items or the specific items on sale. And so now there are also something called categories. So we click on each categories, everything below that changes. So only the items within that category shows up here, right? So we can see on top, there is something like this, right? Category equal to. So till now, when I showed you over here, I just showed it in parts of directly like this, when users pass into forms. And even the previous practical, we passed it into a login form. But in the practical 2, what we're going to do is we're going to pass our SQL query, our SQL injection directly into the URL. So URL is also possible. It's not just when we have forms, but even in URL. So if you see over here, every time I click something, it changes. So we know that there is something going on over here, right? Only what is stored in these tables are going to come here. In these categories are going to come here. So we can just try to check if it's vulnerable. So to try to check, we can just put a single quote character. So just one quote, and you can hit enter. And if you see, we're getting an internal server error. So anytime you want to understand if a parameter, or if your parameter that you're looking for is vulnerable, then all you have to do is put a single quote. That's it. Sometimes single quote would not work. You might have to put double quotes, but in this, double quotes has no meaning whatsoever. So in some cases, you would have to put single quotes. So in this case, I'm putting double quote. I'm putting single quote. And now I need to give my SQL query, my union query, right? So if I need to give my union query, I need to give union, select, and the number of columns. That should be same as the number of the corporate gift query columns, right? So I need to find out how many columns are there. So for that, I need to give space. But keep in mind that this is in the URL. When we're putting into the form, we can give space directly. But since it's in the URL, we can't just use space. We have to URL encode the space, right? So how do you URL encode it? There are two ways. You can use %20, or you can just use plus, like this over here. Like for corporate gifts, it's two separate words. They just use plus. So you can use plus. We'll just say union plus union plus select plus. And now what we can do is we can give you can give 1 or 2 or 3 or 4, but the best way to do this is always give null and test it with null. So it's the best way to do it. So now what I did is I just gave union select null dash dash and then plus for space. So now if I hit enter, it again shows me an error. Okay, so that means that it does not have just one column. So that means it has more than one column. So let's try with more column. So again, we can give comma null. So now we're trying with 2 columns. Again, it says internal server error. Okay, so maybe there are not 2 columns in the left side, but maybe there is more than 2. So let's try with 3 columns. Again, we're giving null, and it works. So there were 3 columns in the left side. So now we essentially found the number of columns in the left. So that's pretty cool. Like, it will not work if you give 4 columns. If I can show you, it will not work if you give 4 columns. It again goes to internal server error, because union has this constraint where it works only if the left and right columns are same, right? So union only works then. So 3 columns, and I hit, and it shows up. There is no error now. That's essentially how you use union to find out the number of columns on the left, right? And if you're not using union, you could also use something called order by. So that's another type of simple one. If you can use union essentially, or you can just use order by. They both do the same thing. Order by also does the, but in order by you have to give the number of columns. So if you see over here, if I had given, because I knew it was 3, I gave 3. But if you didn't know, you had to start with 1, and you have to go like that. But you can use order by as well. And you can use also union, but union is the one which I would recommend using, because union gives you more accurate results, and order by has some issues where in some cases order by is not usable, because you might have some subquery issues with order by which you'll not have with union. So that was a second practical. And then we can go on to the third practical over here. So third practical is again union, but this time we're going to retrieve the password and the username. So we're going to retrieve the password and the username. So this time they say that the database contains a different table called users with columns called username and password. To solve the lab, perform an SQL injection union attack that retrieves all the usernames and passwords, and then use the information to log in as the administrator user. So essentially what they're telling us is we know that there is a table called users and it has two columns called username and password. So we need to use the union query or the union operation to find out the username and password of all the other users present here, right? So how do we do that? Simple again. So again, we see here it shows a lot of information. So again, maybe we can try with this. So what? Let's see if there is actually a SQL injection present. So we have to give a single quote, hit enter. Yep, it's present. So when hit single quote and hit enter, we see that internal server error. So we know that it's present. So now what we're going to do is we're going to give plus and give union select. We know that there are two columns on the left because they already said that. So we're just going to use select username and then comma password, and then we're going to give from, and we also know the name of the table, right? So that is users. We know that too. So we're giving users, and then we're going to give our dash dash and then plus. So if we just give this, we should essentially be able to identify if there are actually two columns or if there are more than that. So if you see, it works. So here we see that we got an administrator user and then the password, and then another user called Beaner and then their password, Carlos, their password. So we got three users and passwords. So they just asked us to log in as administrator. So all I'm going to do is copy the password from here, head to my account, type in administrator. So this time we don't need to do administrator, this and all, because we know the password. We got the password. So just paste the password and we're in. We logged in, that's it. Username is administrator. So I can maybe do this again, walk through this pretty slowly. So just that you understand. So I just found out that in this page, there is no form, right? So I cannot just give my query or union query or anything just like that over here. I need a form. So since there is no form, but I see something that is called refine your search, and there is like categories over here. So if I see categories, if I touch these categories, and if I see on top, they keep changing, right? So let's say I go to pets, and I'm just trying to see if this pet category parameter is essentially vulnerable to SQL injection or not. So for that, I just hit a single quote, hit enter, and I see that there's an internal server error. So since there's an internal server error, I'm sure that there is a SQL injection vulnerability. So all I have to do now is I have to use union, right? So let's go at this from the beginning. Let's say we don't know that we know that there's a users table, but we don't know how many number of columns there are. So what do we do then? We have to just type union, and then we have to type select, and then we have to type null, and then dash dash plus. So we don't know the number. Let's just say we know the number of columns, obviously, but let's just say we don't know. So I'm just going to go through like from the basics. So we're typing this and we hit enter, and it still shows us an error. So that means there is not one column. So that means there's more than one column. So let's type and see. So maybe there is two columns. We type in 2 columns, we hit enter, and we see it works. 2 columns works. Okay, so that means there's going to be 2 columns that we need to manipulate, right? So then we can try random names. Because it's a users table, we could try something like uname, and then for the second one you can try pass, right? And you can hit enter, and it's going to throw us an error, right? But if we want to brute force this, we can brute force this, the uname and the password. We can use even burp suite to brute force it. But the only issue is that it's going to take a long time. And if I start showing you how to brute force it in burp suite, we'll probably go way over time just for this one practical. So I'm not going to do that, but I'm just going to tell you that there are ways you can brute force this. You can use even burp suite to brute force. You just have to get this in here, and then you have to use something called an intruder, where you will add your payloads and you'll brute force it. Or you can write your own Python program, or any language program. Python is usually recommended because it's much more better, accustomed for cybersecurity reasons. But other than that, you can use any kind of programming language you want. But yeah, but since we already know that it's username, I'm just going to type in username since it's already given to us, and then I'm going to type in password, and yeah, union select username password. I have to give now the name of the table. So I'll show you what happens if I just type username password. It's still going to show an error because we did not give what table it's from. When we type in null, the value is null. So it's just going to take it in directly that. But here we're typing in username password, specific values, specific columns. So for specific columns, we need to provide the specific table it's from. So that will be from and users. I hit enter now. And as you can see, again, we get the username for administrator, the password for administrator, the username for Wiener, the password for Wiener, the username for Carlos, the password for Carlos, right? And again, like we already saw over here before, that we have to also understand what is being returned on the web page. And based on that, we have to change the positions, right? So for example, I can even show an example over here where I don't give username, but I just give 1. So now what happens, if you see, it again throws an error because there is no 1 which is going to be a column in users, right? So I have to give the specific column that is present in users, and that's why we have to brute force if we don't know the name of the columns. But there are also methods where we can use substring. So I'll be sharing that in the presentation after this, where we can use something called substring. And I'll also show you like an example code that I have, Python code that I've set up to kind of get it going. And I'll like walk through the code and I'll show how to do that. So that's about that for the third practical app. And let's go ahead into the next part, which is blind SQL injection. So blind SQL injection is essentially an advanced version. It's totally advanced. It's not simple. I'll just say that, because blind SQL injection takes a lot of effort, it takes a lot of time, and it takes a lot of patience essentially, because in blind SQL injection we do not get any direct results. Like in SQL injection, when I showed you the before ones, we were either able to log in directly, or we were able to get that error, that internal service error, or we were able to get some kind of clear indication that there is a SQL injection. But in blind SQL injection, we'll not get any kind of clear indication that there's going to be SQL injection there. So the only ways that we can find, or we can analyze and understand that there is a blind SQL injection vulnerability present on that page, is using time inconsistencies or error codes for the web page, right? So time inconsistency, we can manipulate that by using the sleep function that's shown over here, or we could check for maybe like a 500 return code, or a 302 return code or something. Let's say, for example, that if you're logging into a page and the response code that you want is 302, which redirects to a web page after you log in, right? It redirects to your account page. So when that happens, that means it's right. But when you give some kind of SQL payload and it does not go to 302, but it goes to 200 or it goes to 400 or something like that, then you know that there is some kind of, maybe there is a SQL injection vulnerability there, right? Maybe a blind SQL injection vulnerability could be exploited by you. Similarly, the sleep function. So I'll show an example of sleep function as well after I explain what we're going to do. So essentially, blind SQL injection, again, as I said, like before, we had to, if you don't know the username and password were the columns, you had to brute force them. And the brute force is where it's like, it's like really time consuming, since you have to brute force it character by character. You can't just brute force it like password or just the username, just like that for the column. You have to brute force it character by character. So if you're trying to find out the column name for username, you have to find out first U. So there are already so many possibilities that it could be. It could be a small u, or it could be a small alphabet. So that's already 26. And then the capital alphabets, which is another 26 set. And then the numbers, it could be even numbers. There is no saying that a user would name their database, their name columns only after letters. They could do it in numbers too, or special characters. So that exponentially increases the time and the effort required to find even just the first letter of the column or the database or the password that you're going to find, right? So imagine if the column name was like 10 letters or 12 letters. It's going to take exponentially long time. So we have to be really patient, and we have to brute force character by a character. So let us take an instance or an example where there is a login page, but that login page is immune to like basic SQL injection. So we can't just type in admin single quote dash dash space and enter. We can't just go in like that. That's not possible. So what do we do then, right? So here we need to find the administrator's safe code located in another table located within that database. So not only do we need to find the administrator's password if we want to log in, we have to find the administrator's safe code, which is not only located, which is located in the database, but it's located in some other table, not in the same table that the users' passwords and their names are located. So this is going to be pretty tricky. We have to go through a few things to find it out. And in this situation, a really useful operation is a substring operation. So the substring operation can be seen over here. This is just a syntax for substring operation. So substring operation is essentially substring, and then a database, and the database is essentially the query. I'm giving the query over here to find the name of the database, and then 1 and 1. So essentially what happens here is we are going to use the substring function or operation to search for the first character. So that is what this 1 means, right? This first character in this database, first database, and return true if it starts with T. So if this first character in the database name starts with a T, then this substring will return true. Otherwise, it'll return false. So essentially, we'll go from A, B, C, D, E, F, G. For every single thing, we'll try this substring out, and we'll be able to find out if it is actually true. If the username or if the column actually starts with a U, the username column will actually start with a U or a T or E, or if there's some other. So it'll take a long time like that. So similarly, once we find the database, now we need to find the tables that are present in the database. So using the previous query, we'll be able to find the database. So in the username field, what we're doing is we're giving this query. So that's just essentially, you can give 1, -1. I just gave -1 like that, but you can give 1 because this is anyway going to go false. And only this will return true or false because there is an OR over here. And as I said, SQL is case insensitive. So you can give OR small or capital. I have been giving it capital in the previous slide, so it'll be easy to understand. But as you keep coding and typing, you just get used to it. So it's fine, whatever you give it to us. And after OR, so this will return false. And this substring, if there is a database that is the first string starts with T, then this is going to return true. And this username will then come as true. Otherwise, it'll return false, right? And since we have the double quotes over here, the password is just going to be not taken in. Next, when we go to the next one, so using that, we can find the database name. So that already will take a while to find the database name because we are going letter by letter. So the first letter, we'll find out the first string, first character, we'll find out the letter, second character, we'll find out the letter, third character, fourth, fifth, sixth, seventh, however long the database name is. So once we're done with that, now we need to find the table that are present. So for that, what we do, again, this is going to come false. So we give that false, or then substring select. So again, now we're going to give a subquery over here. So now you see how subquery comes into help, right? Subquery has been a lot of help for us in insert, and it's also helping us over here. So within the substring, we're giving a subquery, and that subquery we're giving select group concat. So group concat is essentially what it's doing. It's taking all the table names and just grouping them together. So there are like different table names that are the same name. We'll just group it together from information schema.table. So information schema in SQL, in structured query language, or in MySQL, is kind of like the brain or the storage where all the information about all the tables, all the databases, all the columns value, every information is present in the information schema. That's like the structure of the database. So what we're doing is we are selecting the table name from information schema dot tables. So within information schema, we're taking the tables element, and we're selecting the table name from that, where the table schema. So table schema essentially means database. Table name is table name. Table schema, table underscore schema means database. So from the previous sequence, from this previous year, we would have found out the name of the database. So I'm just taking, for example, that it's safe deeds, just randomly, and I'm giving second. So here we're looking for second character. That means we already found the first character of the table name. So we're looking for the second character, and then we're checking if it is A, and then again dash dash space. So now we head on. Once we found out the table names, we need to find the column name. So again, we'll use select group contact column name from information schema dot columns, where table underscore name equal to the name of the table, whatever table name we found. And then again, we have to brute force that to get the column name. Once the column name is done, then we'd have to get the value within the column. So that is, again, we have to give another substring, and again we have to go through the exhaustive process to find that the safe code, essentially, right? That means there's a safe code that will be there. So again, as a human being, this would be a very exhaustive process. Hence, we would need to automate such tasks. Thus, we could use Python to automate this for us. And there is also a tool, actually, a tool called SQL Map, that performs the SQL injection operations for you. It already has all of these SQL injection queries preloaded in it. So it performs them, like it brute forces them for you, which could make life much simpler. But again, many of the websites and web applications right now, they kind of block SQL Map because they're aware of which ports SQL Map uses. And so they have like kind of web application firewalls that block SQL Map. So again, it comes down to manual or with Burp Suite. Burp Suite, according to me, is one of the best tools there is out there for any type of SQL injection or even cross-site scripting or any of the other stuff that we're going to talk about. Yeah, okay. So before we head into cross-site scripting, I just want to show you the code that I have, the Python code that I was talking about. And yeah, so first, so this SQL injection 1.py is going to be used to find out the database name. The SQL injection 2.py will be used to find out the table name. The SQL injection 3.py will be used to find out the column name. And finally, this will be used to find out the value from the column. So as you can see over here, this is just, I'm just importing a few Python libraries so that I can use them below. I'll just explain the basic structure of how this Python program works. I'm not going to go too deep into it, just the basic structure so you can understand and get an idea of how much work is involved in it. So first, I'm giving a letters variable that is going to contain lowercase characters A to Z, uppercase A to Z, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, open bracket, close bracket, comma, and many other things. And then this is the URL that I'm going to attack. So this is like essentially a private NYU URL that I use on my end. And then cookies. So I'm giving another variable to store my cookies. And I'm setting a counter, which is going to be initialized at 0. And I'm setting another letter counter, which is going to be initialized at 1. So this letter counter, I'll show you where it is being used. And final. So this is the final, which is going to store the final string or the final name of the database or the column name or the table name or the final safe code or whatever you want, right? And I'm giving 2 while loops and I'm checking if they're true. So when I come here, first what I'm going to do is I'm going to check if the counter is greater than the length of the letters, right? So if the letters over here and if the counter is greater, then we know that we don't need to continue. So I'm just going to break and I'm going to set the current character to letters of the counter. So what this does is essentially it takes this counter variable 0 over here and it takes this letters and what is their 0th position of letters. So 0th position of letters here, that will be A, small lowercase a. So it will take that in over here and store it in the value of current, right? So what I'm giving in as the data is this is going to be the email or the username field. This is going to be the password field, and I'm passing in my payload over here, just as we saw in the presentation. I'm passing in my payload over here. So that is going to be, this is going to come out false, obviously. And then I have my OR, and this is a substring. And I'm passing in the database, just like version, we're passing in database over here. And now here I had to pass in number 1 to identify the first character. So that I'm giving it over here, letter counter, right? So I'm setting this as 1 and I'm increasing that letter counter every time. Every time I'm incrementing it. So this will go 1, 2, 3, 4, 5, 6, 7. How many ever are there, it will keep on going. And the current I'm giving over here. So the current is going to be this over here, letters of 0, 1, 2. Again, counter is also increasing. So it will change from 1, 2, 3, 4. So it'll go A, B, C, D, E, F, G, H, I, J, K, and again capital A, B, C, D over here. So this is going to be repeated continuously, right? So this is going to be repeated continuously until we get such. So such is actually why I gave such over here is because in our response page, when we log in, there was a text saying, so you have logged in, such is the day. So I just took a random word from within the page. So if you're logging in and if it says, yay, you've logged in, you can even take that yay word and you can give here. So once that is there, it will keep increasing the counter. And if suppose it fails, then it's going to come out and it's going to end, right? It's going to end. And so this essentially will help us find the username or the database name, but it'll take a while. So even the database is simple, like it'll take maybe 5 to 10 minutes if your database name is small. That it took just 5 minutes for me. And the SQL injection 2 is essentially to find the table name. So again, if I show you a select group concat table name from information schema.tables, where table schema is equal to log me in. So table schema is database. I found out from the previous SQL injection payload program that my database name is log me in. So I got that here and I run this again. So when I run this, I'll get my table name. So the next one, if you see over here, I'll have my table name over here. See, table name is equal to secrets. I found that. So after that, I found the table name and I'm going to use that to get the column names. So once I find the column names, finally, I can go here and I can give from secret. So I know that the column name is value. So I'm getting select binary group concat value from secrets. So this is the table name and this is the column name and this is the value within that. So I'm just gonna get that out and I'll get my final safe code that I wanted. So that was essentially just an explanation of a basic code that I just wrote. It's pretty simple for blind SQL injection, because if we are to do this on our own one by one, it's going to take a while. But this way, it's going to be pretty simple. If you use, it'll still take time. It'll still maybe take like an hour 30 minutes. But if you're willing to wait it out, then it's a very good kind of way to go ahead. And again, SQL map, if you're interested, you can go and take a look at it. SQL map is very easy to learn. I'm not going to go into SQL map because we need to go cross-site scripting. We need to cover a lot more. So I'm just going to leave SQL injection with that. And if you're interested, you can go ahead and you can learn more about that. And next is cross-site scripting. So if you had seen my intro for SQL injection, I said, I know your DB. And for cross-site scripting, I'm just saying, I know you now, because cross-site scripting is, it's much more than just basic DB access or anything. Cross-site scripting is much more. And it's usually, it's one of the most exploited vulnerabilities out there, because a lot of developers and programmers, they kind of do not sanitize. Again, sanitization plays a very important role over here. If you do not sanitize your input, it's always going to backfire and it's going to bring about a lot of problems. But yeah, let's go ahead and see where cross-site scripting.
Yes, Stafford.
Yes, sir.
Shall we have a small break? Then we'll continue by 10:45.
Sure. Yes, sir. Sure. No problem.
Okay.
Sure.
Okay. Participants will have a small break now. We will again back by 10:45. Please.